Great seeing you here. My name is Luc de Koster, founder of the Koster Academy, and in this video I'm going to talk about the precedence diagramming method and what is the difference when we start calculations from 0 or 1. There are two ways to do the calculations. Some people like to start from 0 when we are looking at events, which basically comes from the PERT and the arrow diagramming methods, or we start from 1 when we are and basically start our calculating calendar days. A day starts in the morning, finishes in the evening. But before we continue, don't forget to click on the subscribe button, click on the bell button, and every time we have a new video, YouTube will inform you about it. So let's have a look about these numbers. Are we going to use cardinal or ordinal numbers? No, both examples, both solutions are correct, although there are some small differences when we will compare the solutions. And we can already see it when we will be looking at this example. Let's have a look. We have three activities. Activity 1 with a duration of 3 days, activity 2 with 5 days, and activity 3 with 2 days. Now on the top we find the ordinal numbers, so the days, the day 1, 2, 3, 4 up to 10. And on the bottom we see the cardinal numbers, the events. Activity 1 starts at the moment 0. These are points in time. And we find for the starting of activity 1, it's in the point 0, event 0. And we finish in event 3. Activity then will start, or the next activity, activity 2, will start in also point 3, event 3, which is equal to the finish event of activity 1, and activity 2 will finish at point 8, which is the finish event of activity 2. For activity 3 we find basically the same things, but now we can already start writing it as a formula, as a let's say an algorithm. So the start of the follow-up activity is equal to the finish event of the predecessor, and the finish or the end time of the activity is equal to the start plus the duration. And this is completely compliant with what we see in the graph, and these are also the same formulas like we have in activity on the arrow methods, or in the arrow diagramming method, or in the PERT method. The advantage here is that we can have decimals, so when we are doing the calculations we can use 5.73 and so on. We have a little bit more flexibility in the calculations. When we use the ordinal numbers, we see that activity 1 starts at day 1 at 9 a.m. and the finish is at day 3 at the end of the day. So activity 2 can only follow or start the next day. So the start of 2 is the finish of the predecessor plus 1. This is in this case day 4 at 9 a.m. And this activity 2 will finish on day 8, which is basically 4 plus 5 minus 1, which is day 8 at 5 p.m. When we see the number of days between 8 and 4, it's 8 minus 4 plus 1 because there are 5 days. So when we do the counting like that, you have to be a little bit careful to count it properly. It's not rocket science, but it's a little bit strange when we're calculating with this, and some people prefer the calculation like it is done with the cardinal numbers, the events. We can write this as an algorithm too, so the start of the predecessor is equal to the the start of the successor is equal to the start of the predecessor plus 1, and the finish of the activities is equal to the start of the activity plus the duration minus 1. Now let's have a look at this in a more exercise format. And we have again our three activities, activity 1, 2, and 3. They have the same duration, 3, 5, and 2 days. When we look at the forward pass, we know that the early start of the successor is equal to the early finish of the predecessor, and the early finish of the activity is equal to the early start plus the duration. And we can apply this here. Activity 1 starts at early start is 0. So the early finish is early start plus 3 is 3. And now we can find the early start of activity 2, which is equal to the early finish of activity 1, which is 3. And we find the early finish of activity 2, which is equal to the early start of 2 plus 5, gives us 8, same number that we had before. For activity 3, now we can say the early start of 3 is equal to the early finish of 2, which is equal to 8. And the early finish of 3 is 8 plus 2 is equal to 10. Now we can do the backward pass, and when we look at the formulas, we have the same relations between late start, late finish, and the duration. So we can say, based on the equations we have before, is that the late finish of an activity is equal to the late start plus the duration. Since we are calculating from the back, we will start with the late finish. So we have to know what is the late start as a function of the late finish. And when we change the formula, we bring d to the other side. So we bring the late start to the left-hand side and the late finish to the right-hand side. We can say that the late start is equal to the late finish minus the duration. And we can do the same thing for the late start and the late finish of the late start of the predecessor, of the successor, and the late finish of the predecessor. We can say in this case that the late finish of the predecessor is equal to the late start of the successor. And now we start from the back. So we start from a late finish of 3 is equal to 10. We apply the formula. We see the late start of activity 3 is late finish minus the duration. It gives us 8. We now do the same thing for the late finish of 2, which is equal to the late start of 3, which is equal to 8. And from this we can calculate the late start of activity 2, which is equal to the late finish of 2 minus 5, which is then equal to 3. And for the last activity, we can calculate here, we can say that the late finish of 1 is equal to the late start of 2, which is equal to 3. And we find that the late start of 1 is late finish of 1 minus 3. So this is also equal to 0. So let's now have a look at the next, or the formulas that we can derive from this. We know that the start of the successor is equal to the finish of the predecessor. We have the finish time of the activity is start plus duration, E. And in the forward pass, we have the formulas that the early start of the predecessor is equal to the early start of the successor is equal to the early finish of the predecessor, and the early finish of the activity is equal to the early start of the activity plus the duration. For the backward pass, we apply different formulas. So we have the late start of the activity is equal to the late finish minus the duration, and the late finish of the predecessor is equal to the late start of the successor. So we have those formulas when we have to do the calculation starting from 0. Let's now have a look when we start from 1. Again, we have the activities, activity 1, 2, and 3. They're exactly the same as before. There is no difference. And we take the formulas that we already derived before. So we know that the early start of the successor is the early finish of the predecessor plus 1. And the early finish of the activity is the early start plus the duration minus 1. For activity 1, we start at 1. So the early start of 1 is 1, day 1, and the early finish of 1 is early start plus 3 minus 1 is equal to 3. Now we can go to the next activity, and the next activity we can start the day after activity 1 is completed. So the early start of 2 is equal to the early finish of 1 plus 1, which is equal to 4. And now we can calculate the early finish of 2, which is early start of 2 plus 5 minus 1 is 8. Next thing, for activity 3, the early start of 3 is early finish of 2 plus 1, and the early finish of 3 is early start of 3 plus 2 minus 1, which gives us 10. And we see that for the early finishes, we have the same numbers as with the other method, but be careful, for the early starts, we have one number different, and that can be sometimes confusing. Now, when we go backward, we can also write, like we did before, the late finish and the late start, but we have to determine the late start as a function of the late finish. So we can say that the late start of an activity is equal to the late finish minus the duration plus 1, and the late start of the predecessor or the successor, and what is the relation with the late finish of the predecessor. So when we adjust the formulas, we can say that the late finish of the predecessor is equal to the late start of the successor minus 1. Let's now start with the calculation. So we start with the late finish of 3 is equal to 10, and like we did in the previous example. We can calculate the late start of 3, which is equal to the late finish of 3 minus the duration plus 1. So 10 minus 2 plus 1 is 9. For activity 2, we can find that the late finish of 2 is late start of 3 minus 1. So it's 9 minus 1 is equal to 8. And now we can calculate the late start of 2, which is the late finish of 2 minus 5 plus 1 is equal to 4. For the last activity, we can say the late finish of 1 is late start minus 1 is equal to 3. And we can also now calculate that the early finish is equal to the early start minus 3 plus 1 is equal to 1. So we find the similar results as before for forward, back, and backward, forward pass and backward pass. We can calculate the slack, it will be the same. And when we look at the results, when we put this in a graph, the graphs are identical. The Gantt chart will show the same levels, the same data. Now, when we look at the formulas, like we did before, we know that the start of the predecessor is the start of the successor is equal to the finish of the predecessor plus 1, and the finish of the activity is start plus duration minus 1. For the forward pass, we can say that the early start of the successor is equal to the early finish of the predecessor plus 1, and the early finish of the activity is equal to the early start plus the duration minus 1. For the backward pass, when we have the formulas that we deducted before, we can say that the late start of the activity is equal to the late finish of that activity minus the duration plus 1, and the late finish of the predecessor is equal to the late start of the successor minus 1. So this was an interesting video about the different calculation methods. I know a lot of people have discussions and problems with it. They are basically similar. They have advantages, disadvantages. Using the cardinal numbers gives you the possibility to use durations with decimals, which you cannot do with the ordinal method when we start from 1. The method starting from 0 may be more natural for most people. Now, when we talk with calendars and with days, we typically always start from 1. We start from a specific day. Day 0 doesn't exist. The first day of a month is the first. Whatever the first day of a week is, that day of the week, there is no day 0 anywhere. Anyway, this is important to understand. Also to understand that you may have some small differences related to the early start of the activities, whether you're using a method started from 0 or a method started from 1. And typically, from my experience, when we look at the exam, they typically start the calculations from 1. Maybe different in some cases, so be careful when you have those questions on an exam. You have to be sure which method is being used. So that was it. Don't forget to click on the subscribe button, click on the bell button, and every time we have a new video, YouTube will inform you about it. Thank you very much, and I'm looking forward to seeing you in our next videos. Bye-bye.